Guys, today we're going to talk about Lewis dot diagrams. So you're going to need a pencil and a paper to take some notes on this, somewhere safe where you can keep them. All right, so some important pointers before we get started. These are review pointers, so just remember them. So the octet rule states that most atoms are stable or happy when they have 8 valence electrons. So remember, valence electrons are the outermost electrons of that an atom has. And the maximum number that one can have is 8. So you should never see more than 8 when it comes to valence electrons. So recall that noble gases are stable or inert or non-reactive because they do have 8 valence electrons. So they have a complete electron configuration. So there's this complete octet. There are some exceptions to this rule. Hydrogen and helium are going to be more stable with just 2 valence electrons, and this is because they are in the 1s energy level, and it only has 2. All the other energy levels have 8 electrons. The one energy level 1 only has 2. So that is why they are the exception. We might recall that we've been talking a lot about bonding lately, and that is because atoms are stable or become stable by forming chemical bonds. And we've talked about the 3 different types of bonds. So ionic, that's when elements or atoms transfer electrons. We've talked about metallic, when we have a sea of electrons that's just shared between a metal element. And then we've also talked about covalent bonds. So that's where electrons are shared between 2 particular molecules. And we're going to show what these covalent bonds sharing of electrons look like using Lewis dot diagrams today. All right, so just a brief overview of a Lewis dot diagram. So this is a structure that shows us a simplified model representing the valence electrons for an atom. And it's especially helpful because it only shows valence electrons, which are the only electrons that are actually involved in bonding. All right, so the first thing we need to do when we draw it for individual atoms is to write out the chemical symbol. So our example here is for silicon. We need to determine the number of valence electrons. So remember, this is the group number. So let me show you what that looks like really quick. So if we're on the periodic table I've given you, and we come up to this first row, it's 1A. So that means all of the elements in column 1A have 1 valence electron. We go to 2A, all of these have 2 valence electrons. 3A, 3 valence electrons. 4A, 4, and so on. When it comes to the D block, these ones do not correspond with their number. So these ones all, for the most part, have 2 valence electrons. So only the A, the number next to the A tells us what's going on in that column. So I highly suggest you highlight that and just kind of give yourself a pointer that tells me the number of valence electrons in the column. All right, flipping back to the PowerPoint. So we determine the number of valence electrons for silicon. It is in group 4A, so we say it has 4. Then we're going to start on the right-hand side, and we're going to draw counterclockwise. We just drop them as we go. 1, 2, 3, 4. If we had more than 4, we would keep going until we had a total of 8. But since silicon only has 4, it only has 4 around it. So remember, Lewis dot structures only show valence electrons. So silicon actually has it has 14 electrons. We don't show all of them. We only show the valence electrons. All right, now we're going to talk about doing it in terms of a molecule model. So in this case, we use dots and lines to represent shared electrons. So you'll see here, there's 2 separate ways we could draw this. We could use dots to represent the shared electrons between the 2 atoms, or we could use a line. When you see these alone, away, not shared in between 2 atoms, these are called lone pair of electrons. So this oxygen has 4 shared electrons and 2 pairs of lone electrons. So electrons are always paired. We never see odd numbers of electrons, always even numbers of electrons. So the way that we see it here, we've got pairs of lone electrons, and then we've got some pairs of shared electrons. And you can see that they can be written in 2 different ways. The lone pairs are always just dots, no lines there. Okay. So here are steps for drawing covalent Lewis dot structures. It's pretty detailed, probably gonna wanna write them down somewhere. So the first thing we do is add up all the valence electrons of the elements that we have available to us. We're gonna divide that by 2 to get the pairs of electrons, because remember, pairs is what gives us our dots or our lines. And then we're gonna arrange our atoms around a central atom. So when I do my examples, you're gonna wanna watch closely. Carbon makes a really good central atom. If carbon isn't available to you, you're gonna pick the molecule or the atom with the most unpaired electrons. We're gonna draw a single bond between the central atom and the outside atoms, keeping it simple. We have to keep track of how many electrons we're using. So when we do this, it's kind of like we're going to the grocery store and we only have $10. If we only have $10, we cannot spend 12. So the same thing happens when we're drawing our Lewis dot structures. We have to make sure that we use all of the electrons we have, but we don't use more, we don't use less. So after we've drawn that single bond, we're going to add lone electron pairs to make sure that every one of our atoms is stable or happy. So that means that they have 8 electrons around them, either shared or by themselves, and 2 for hydrogen. Once we know that atoms are happy, then we're good to go. If they aren't, we might need to use some of those outside electrons from the outer atoms, not the central one, to create double or triple bonds. And I have one example of that. All right, these are the practice ones we're going to look at. So let me pull up my, okay, so the first one we have is H2S. So that means we have 2 hydrogens, and I like to do the elements in different colors just to kind of give me a better idea of what's going on. So we've got 2 hydrogens. They each have 1 valence electron, and I know that because they're in row 1A. And then we have 1 sulfur, which has 6 valence electrons because it's in row 6A. So 1, 2, 3, 4, 5, 6. And then we think about how they would share. So I know that hydrogen only needs a maximum of 2. So that means if this hydrogen shares this electron on this side with sulfur, and this one shares with this one, hydrogen will have 2. Each of the hydrogens will have 2. And then sulfur will have 8. So let's first off just make sure we've counted everything right. We know that hydrogen has 1 each, so that's 2, 3, 4, 5, 6, 7, 8 valence electrons to work with. So we've got 8 valence electrons, which is 4 pairs. So let's get drawing. So I'm going to put sulfur in the middle. And the reason why I put sulfur in the middle is because when I look at hydrogen, it only has 1 possible spot to bond, whereas sulfur has 2 possible spots to bond. And remember, if I don't have carbon, I'm going to put the atom that has the most possible spots to bond. Now I'm going to draw its valence electrons around it. And the place where I want my hydrogens to share is going to be here and here. Now, when I look at this, I know that if I surround this hydrogen here, it has 2 valence electrons, which I know is okay for hydrogen. This hydrogen has 2 valence electrons, so that one's good. 2. And then if I surround everything that's surrounding sulfur, it has 1, 2, 3, 4, 5, 6, 7, 8, which is good for sulfur. If I wanted to draw this kind of with lines, I know that sulfur is in the middle. These shared electrons I'm going to draw as a line. And a line counts as 2 electrons. I'm going to draw these shared ones as a line. And then these are my lone pairs. So they are going to stay paired on the sides that I had them originally. All right, so that was our first example. Our next example is, let's do HCl3. Okay, so this would be hydrogen monocarbon, it's chloroform. Anyway, so we've got hydrogen, which has 1. We've got carbon, which has 4. And we've got chlorine. Chlorine is in the 7A column, so it has 7 valence electrons. So it looks something like that. And we have 3 chlorine, so 3 times 7 is 21, plus my hydrogen is 22, plus my carbon is 26. So I have 26 valence electrons, which is 13 pairs. And remember, Mrs. Kemp said, always put carbon in the middle. So I'm going to put carbon in the middle. I'm going to do this one a little different this time. Instead of drawing my valence electrons here, I'm just going to start by drawing pairs. So I'm going to put my hydrogen here, and I'm going to draw a bond between them. So now I've used one of my pairs up, so I'm going to subtract 1. So now I'm at 12 pairs. Then I'm going to add, I have 3 of these, right? So chlorine, chlorine, chlorine. I'm going to add a chlorine up here. And I've used another pair. So now I'm at 11. I'm going to add another chlorine here and one here. So now I've used 2 pairs. So now I'm at 9. So let's double check to see who's happy right now. Hydrogen's happy because it only needs 2 electrons, and this line counts as 2 for hydrogen. Carbon needs 8, so let's count around it. Each line counts as 2. 2, 4, 6, 8. So carbon is happy. Now we have to look at our chlorines. Right now, they only have 2. So we need to make them happy. We can do that by adding pairs, lone pairs. So 1, 2, 3, 4, 5, 6, and that line counts as 7, 8. So I just used 3 more, so I'm going to subtract 3. So now I'm at 6. Now I'm going to come over to this one. I know I need to do 1, 2, 3, 4, 5, 6. Line counts as 7, 8. So I'm going to subtract 3 again. Now I'm at 3 left. And I'm going to come down to this last one. 1, 2, 3, 4, 5, 6. And the line counts as 7, 8. And I have 0 left. I spent all my money. Perfect. And all my chlorines have 8 around them. Last one. This one's a little trickier. This one is cyanide, HCN. So hydrogen has 1 valence electron. I know that because it's in row 1A. Oops, this is a little blurry. Carbon is in row 4A, so it must have 4 valence electrons. And nitrogen's in row 5A, so it has 5 valence electrons. So remember, carbon always goes in the middle. And we have 1, 2, 3, 4, 5, plus 5 is 10 valence electrons, which is 5 pairs. So let's start drawing. Let's put hydrogen on one side and nitrogen on the other. Now we have, oh, that was 2. Now we have 3 pairs left. And we know hydrogen's happy because it has those 2. That line counts as 2 for hydrogen. But carbon only has 4. It needs 8. Nitrogen only has 2. So how could we make this work? So the first thing we could do is we could try to put valence electrons, pairs, around nitrogen. And I have 3 pairs. So if I did that, I could check nitrogen's happy, but carbon still only has 4 electrons around it. So to fix this, what we end up doing is we end up pulling this pair and putting it into a double bond. So we do that. So we double bond. And when we check, now we have 1 or 2, 4, 6, 8 around nitrogen, but only 6 around carbon. So carbon's still unhappy. So now we're going to take this pair and we're going to move it into the triple bond. Now when we check, we've got 2, 4, 6, 8 around nitrogen, 2, 4, 6, 8 around carbon, and 2 with hydrogen. So everybody's happy, and we've only used 2, 4, 6, 8, 10 electrons, which is how many we had to use. All right, so you are going to be working on some practice problems today. Good luck.